Hello and welcome to Venn diagrams. Now this is another alternative, you can say, diagrammatic technique to test the validity of syllogisms. Right now we have tested syllogisms with the help of formal rules. You can also call them syllogistic rules. Very popularly they are also known as six rules because they are six in number, so we use to test the validity of syllogisms. Now Venn diagrams, or more precisely I will say, it is Venn-Peirce diagrams, which are also used to test the validity of syllogisms. Now, we have already discussed that what are Venn diagrams. We have also come to know that Venn and Peirce both have contribution to the diagrams, and we know the diagrams of categorical propositions, right? So we need to use that technique for categorical syllogisms. Now, if you remember, all the Venn diagrams, like say suppose the A, the E, the I and the O Venn diagrams or Venn-Peirce diagrams for categorical propositions were drawn like two intersecting circles, right? We have drawn two intersecting circles as the basic diagram, and after that we have gone to either shade it, or we have gone to put a cross mark or X mark as they call it. Like suppose if you remember the A diagram, so we will basically shade this part, right? For an A proposition, if this is S and this is P, this is S, this is P, this is S, this is P, this is also S and this is P. So all S is P is represented like this. If you remember E proposition, it is represented like this. Like we will basically shade this portion, right? Like here we are shading this portion. So we have to completely shade it off. Right now, since I am using a marker or you will be using a pen, so even these kind of lines will be enough to show that you have shaded it off, right? Now, if you remember the I kind of proposition, here the common part is having a cross mark or an X mark, and in O proposition, we put the cross mark or X mark over here. So we know that these are basically the Venn-Peirce diagrams. If you remember that these two are basically the contributions of Venn, and these two are basically the contribution of Peirce. So therefore we call it Venn-Peirce diagrams. Now for syllogisms, what we need to do? We have to represent three terms, right? Because every syllogism is having three terms, and it is also having three propositions. Now, the basic idea of Venn-Peirce diagrams for syllogism, what we do in Venn-Peirce diagrams for syllogism, the first and foremost thing which we will be doing is that we will be drawing three intersecting circles like this. You can draw it like three intersecting circles. You can call this one as S, this one as P, and this one as M. Alternatively, you can also draw it like this, like if you draw two circles like this, and you can draw a circle like this as well. So both these diagrams, if you take this diagram or you take this diagram, it is one and the same thing, because after that what will follow is something which we will be which is important for us to understand. However, you can take this diagram as well as this diagram. I am more comfortable using this diagram, so I use this diagram, but you can always use this diagram. In fact, to put S, P or M is also nothing sacrosanct about it. You can put S here, P say here, and M here. There is absolutely no problem. But I keep it like, I keep this left one as the S, the right one as the P, and the below one as the M. It depends, because this is the minor term, this is the major term, and this is the middle term. That is the idea. So since we will be having in syllogisms three terms, so we will be using this kind of diagram, or this is the diagram which Venn has proposed in his original paper in 1881, as well as in his symbolic logic book 1881, the symbolic logic, as well as the paper which is a seminal paper on syllogistic logic. You can check. Now, what to do? What to do with this diagram? How to understand? Like suppose if I take a very basic example and try to understand that how we will be drawing syllogisms over here. Now suppose if we take the example of A1, right? So we know that how to write this one. we know that since it is the first figure, so this will be like this kind of structure, and we know that this is all M is P, this is all S is M, and this is all S is P. So I will also put the copula here so that we see it like this. Now if you remember also that we have also talked about the Boolean representation, right? So the Boolean representation of this will be M P bar is equal to 0, right? Because the part of M which is not there in P will be shaded off. Then here it will be SM bar is equal to 0. That means the part of S which is not there in M will be shaded off. And this is SP bar is equal to 0. This is something which we know because we use when we are studying categorical proposition this expression, right? But when we are talking about diagrams or when we are talking about syllogisms and diagrams, so we have the major premise like this, the minor premise like this, and the conclusion is like this. So the representations have come like this. Now, what this Venn-Peirce diagrams actually tells you, it says that if we draw the premises, then the conclusion should come out while drawing the premises. That is the idea. That means that if you draw these two propositions, then this should come out. That means that once I draw this and I draw this, so this is already represented in the diagram. Now, how to diagram it? Let us try to understand. The first proposition says MP bar is equal to 0. Now, what it says is the part of M which is not there in P is empty. So, if you see, this is the M circle and this is the P circle, right? So, while drawing Venn diagrams, try to forget the third one, the third circle, okay? And just consider these two diagrams, the M and the P one, right? Now, we have M, we have P, and it says that MP bar is equal to 0. That means the part of M which is not there in P. So, if you see the part of M which is not there in P, I am shading it off completely, right? So, for shading, I am basically drawing some lines in between, but you can completely shade it off. But since you will be also using a pen or something, so it is not easy to completely shade it off, but actually it is completely shaded off, right? So this is the understanding. I have completely shaded off. It is like this. You can, if when we were teaching it in the blackboards or whiteboards, it was easier. We used to hold the chalk and we can very nicely put it or shade it off, right? Because that was easier. Or suppose if you are using a software, or drawing software, so it is very easy to fill the paint over here, right? So it's easy, but with a pen or with a marker, it is a little bit difficult, but still you can understand that this has been completely shaded off, or this shading means that this part is empty. Now let us see the second proposition. SM bar is equal to 0. The part of S which is not there in M. Now if you see the part of S which is not there in M, now forget the P part. So this will be this part, right? So I will shade this off completely because the part of S which is not there in M, I am trying to shade it off, right? So I'm putting more marks so that it gives you the illusion that it has been shaded off. So this part has been completely shaded off, right? So this is the understanding. Okay. Now, what does the conclusion says? The conclusion says that SP bar is equal to 0. Now try to understand what is SP bar. The part of S which is not there in P. If you see this part, this is the part which it is talking about, right? So this part needs to be shaded off. Forget about this part which has been shaded. Forget about this part which has been shaded, because since you were drawing these two propositions, so they will have other things as well. But by drawing these two propositions, if the whole part which is required, because look, I have not drawn this. What I have done is that I have drawn this proposition and I have drawn this proposition. And by virtue of that, if this is also coming out, then we say that this argument is valid. Now, you know that this is a AAA1 proposition, and if you see it from the 6 rules as well, so you can see that both are affirmative, the conclusion is affirmative, there are three terms, each of which occurring twice. Now if you see the distribution, this is distributed, this is not distributed, this is distributed, this is not distributed, this is distributed, this is not distributed. So with the help of distribution, also you see that neither there is problem of undistributed middle, nor there is the problem of illicit major or illicit minor, right? So we have completely transformed this into a diagram, and by virtue of this diagram we can very easily see that, look, this part has been completely shaded off, which was the requirement of this question. So since this part has been shaded off, therefore this syllogism is a valid syllogism. So AAA1 is a valid syllogism because the premises draws the conclusion, right? So if the premises draws the conclusion, while drawing these two premises, if the conclusion comes out, right? That is the whole idea of deductive logic, or that is the whole idea of any kind of reasoning, right? That with the premises, if you can come out with the conclusion, then the argument is valid. So in Venn-Peirce diagram, what we have done is that we have drawn both the premises of a syllogism, and by virtue of that, the conclusion is drawn. So since the conclusion is drawn, therefore this argument is valid, right? So this was the first example which I wanted to bring to your attention, so that you have some idea that how we draw Venn diagrams. Let us take another example to even have a better idea. Let us take an example with AAA2 only, right? So I will remove all these things, in fact, so it will be easier, because you need to follow everything from the scratch, right? So the if you go more to the basics and from there you start studying, it is always easier and it is always better for us to understand the nitty-gritties of any kind of reasoning. So I am taking AAA2. Okay, so I will take AAA2 and see what and how the Venn diagram will be drawn. Now since it is AAA2, so you know that the middle term will be here, and this is going to be SP, and this is also going to be like this. So it is all P is M, all S is M, all S is P. So we have this as the syllogism, right? So we can also draw the Boolean representation of this. This will be P M bar is equal to 0. The part of P which is not there in M will be empty. This is S M bar is equal to 0. That means the part of S which is not there in M. And what we need, the conclusion remains the same, SP bar is equal to 0. This is what we need to achieve while drawing these two premises. Now let us try to draw these two premises. You can pause the video and check it for yourself as well, that whether you can draw this syllogism. So let us see. We will draw three intersecting circles. S, P and M, right? So we have drawn these three. Now what is the first proposition or our major premise? The major premise says PM bar is equal to 0. That means the part of P which is not there in M. If you see this part, this is the part, right? So this part needs to be shaded off. So I will shade it off. I will shade it off like this. So you can see that this part has been shaded off, right? I will put a little bit of more lines so it looks a little bit, at least with the camera it can be seen that it is being shaded off, or this is like dark, right? Okay. Now what is the second proposition? SM bar is equal to 0. The part of S which is not there in M, right? So the part of S which is not there in M. So if you see, this is the part, right? So I will shade it off. So some part of it is already shaded, no problem. We will shade the rest. So we will shade the rest of the part, right? I will remove this part and I will put some more lines so that you can see that this has been shaded off, right? Okay, okay, fine. Now what is the conclusion? The conclusion says SP bar is equal to 0. That means this part has to be shaded off. Now if you see, this part, right, is basically divided into two parts. One is this part and the other one is this part. How one part is shaded for sure, but then there is one part which is not shaded. So since this part could not be shaded, therefore we say that this is an invalid syllogism, right? This is the idea. Now, since you know the 6 rules, right? So you can also check that what is the problem here. Okay, so we will see that this term is distributed, this is not distributed, this term is distributed, this is not distributed, this term is distributed, this is not distributed. So you see that here the problem is undistributed middle, because the middle term is not distributed in any of the premises. So there will be a fallacy. Here you can call it undistributed middle, or by Venn diagram you can see that a part of the SP bar is not completely shaded. That means since SP bar is not completely shaded, or it is not empty completely, therefore we will call this syllogism as an invalid syllogism. So this was the idea which I wanted for you to understand, that how a syllogism can be shown valid as well as it can be shown invalid. So these two examples very aptly I will say shows that how a syllogism gets valid. When we are drawing both the premises, the conclusion is completely drawn. But then when we are drawing both the premises, the conclusion is partially drawn, or the conclusion is not at all drawn, suppose. In all these cases, this syllogism will be an invalid syllogism. Okay. So these two were basically taking universal premises only into consideration. Now let us talk about universal and particular premise, right? So we will take a universal premise and we will take a particular premise and see that how we need to draw it. And then in the last example, we will see that if two particular premises are taken, so how it is drawn. Okay. So the first two examples were of two universals. The next two examples will be of one universal and one particular, and the last example will be of both the particular propositions. Okay, so we will have enough of idea, and rest of the things we can always discuss in the class. So let us take another example now. What to take? We have taken the first figure, we have taken the second figure. Now let us go to the third figure. So let us take EIO3. Okay, so here you can see that the first premise is a universal premise, it's a negative premise. The second premise is a particular premise and it is an affirmative premise, and the conclusion is a particular premise and also a negative premise. So let us see how to draw it. Now since it is 3, so you know that the structure will be like this, because we know the moods and figures. So all the things, all the groundwork which is required to understand the Venn-Peirce diagram is already taken care of, right? So here will be S and here will be P. And now if we want to see that how this proposition will shape up, so this will be no M is P, this will be some M is S, and this will be some S is not P, right? So these are the three propositions. Now we can also check that what will be the Venn diagrams for this. So the Boolean representation for this. The Boolean representation will be MP bar is equal to, it will be MP is equal to 0, right? Because it is an E proposition, so it says that the common part of M and P will be empty. Here it says MS is not equal to 0, right? So this is and how we will be drawing it and all these things we will understand. And this says that SP bar is not equal to 0. So this is the thing which we want. Okay, so let us start with this, that how we will be drawing this in the Venn diagram. So again, the basic idea is that we will be drawing 3 intersecting circles. Okay, and we will name it as S, P and M. Fine. So these are SP and M, and with this we will check that how to draw these. Now first one says MP bar, that means the common part of M and P, that means this circle and this circle. So this is the common part, right? So we will shade it off because it is a universal proposition, so it requires shading, right? So we will shade it completely, and I will put more lines so that that illusion can come that it has been shaded, right? Okay, fine. Now the next proposition says ms is not equal to 0. Now if you see m and s, okay, so it says that the common part of m and s, that means this part, right? Now this part has to be there has to be a X mark or a cross mark, whatever way you will like to say. Now again you can see that these are having two parts. One is this part and the other one is this part. Now since one is already shaded, that means it has already been shown to be empty. So the idea is that we will put the cross mark here. Okay, fine. Now what is the conclusion? The conclusion says SP bar is not equal to 0. That means in this part there should be a cross mark, right? Or there should be an X mark. So if you see, there is an X mark over here, and therefore this syllogism is valid. Now many of you may have this question that why this X mark is here and not here. But if you see the if you see any particular proposition, there needs at least one cross mark in whichever area. But if you see universal proposition, it has to be completely shaded off. So if this X mark or cross mark is here or it is here, irrespective of that fact, the answer will be always that it is a valid syllogism. Because if you see this, if you see these, when you are saying that SP bar is not equal to 0, you forget about the M and you see the S circle and the P circle. So in the S circle and P circle, if you recall an O proposition, how it is drawn? An O proposition will be drawn like this. S, P, and here there is a cross. So since there is another circle, so it can be here or wherever. Does not matter, but it has to be in this part. So even if there is this cross on this side and not on this side, because in the last example you have seen that one part was shaded but then the other part was not shaded, so we saw that syllogism was invalid. But in this case, if there is this X or cross mark in whichever part, the syllogism is going to be a valid syllogism. So that is the understanding, or that is something which you should put in mind. But then there is something more to it, and something more to it which we will be understanding in the next example. Let us take another example to have or to understand that what is the, or what are certain kind of complications which can come in case of a Venn diagram, right? So we will take an example, like suppose if we take an example of EOO4, right? So let us see that what kind of problem is faced by us in this kind of question, because I can tell you, and you can also understand that this is a negative premise and this is also a negative premise. So since both the premises are negative, forget about this conclusion. No conclusion follows from two negative premises, right? So we know already that this syllogism is going to be an invalid syllogism. But let's try to see that when we will be drawing, how to draw it. So now it is the fourth figure. So this will be like this. Okay. And this is no P is M. This is some M is not P. And this is going to be some S is not P, right? So these are three propositions. We can also have the Boolean representation. Pm is equal to 0. Ms bar is not equal to 0. And here it will be SP bar not equal to 0. I may have used in the last example this not equal to as equal to, right? So if I have used this, because I cannot go back and see, but you can always go back in the video and see. So you can check it that whatever is the representation is something which should be there. For I and O kind of proposition, it is always not equal to, and for A and E propositions, it is always equal to. If there is a mistake which I have done in the last part of the question, so I will put it in the comment, right? So do not worry, but you should always remember that whatever has been taught to you as far as the propositions are concerned, it is the right explanation. Okay, so let us try to understand that how this is going to be drawn. Now, if we have to draw it, we are drawing S, P, and there is another M. Okay, so this is the propositions. Okay, now Pm is equal to 0. The common part of P and M shall be shaded off. So I will be shading this part because this is the common part of P and M. I will put some more lines. Okay, now it looks that it is shaded. Okay, now next is saying ms bar is not equal to 0. Ms bar, the part of M which is not there in S, right? So the part of M which is not there in S. So which part is this? If you see this part, right? So this is the part, and here if you see this part needs to be put a cross mark. So this is the part where we need to put a cross mark. So this part is already shaded off. So we will put a cross very comfortably over here, right? Okay. Now, if we see the conclusion, sum S is not P, right? So sum S is not P. So we need the cross somewhere here in this part. But as you can see, by drawing these two premises, we do not find a cross either on this part or this part. So since you cannot find a cross either on this part or this part, so this syllogism is going to be an invalid syllogism, right? Because we also know that this is a negative proposition, this too is also a negative proposition. So from two negative propositions, no conclusion follows, right? So once we know that no conclusion will follow, so you will also find it with the help of Venn diagram that the conclusion is not coming out. So and apart from that, if you see the rest of the distribution and all these things is taken care of. So apart from exclusive premises fallacy, there is no other fallacy which is there, at least in this question, right? So whatever is the case, but even if there is one fallacy, it will be an invalid argument or it will be an invalid syllogism. So this is going to be an invalid syllogism. Anyways, you did not face much of problem, I guess, so with this question, but with the next question, you may face a little bit of problem, and that is going to be the last example which we will be taking for this lecture. However, we will be taking a lot of questions in the class so that you have a better understanding of how to draw these Venn diagrams, and side by side you can always check it with the help of formal rules, right? Because you know the syllogistic rules and now you will be also knowing the Venn diagrams, so there is always a check and balance system, right? Because you can check it with the help of 6 rules. Even if the question has been asked that okay, you do it with the help of Venn diagrams, you can draw the Venn diagram, but then if you feel a little bit of confused or something like that, you can always use 6 rules to check that whether it is a valid syllogism or whether it is not a valid syllogism. Similarly, sometimes you have forgotten a rule, right? So you draw a Venn diagram and check that whether it's a valid syllogism or not. So it is always a check and balance system, right? So you can keep those things in your mind. Anyways, so let us come to the last question of this lecture, and then we will be taking a lot of examples in the class. What can be the last question? Let me think. A last question can be something where we need to have some problems, right? So we will face some problem, and by virtue of that problem, we will learn certain things, right? So always remember that problems are not, I will say, a problem, right? What is the problem? Is to leave that problem over there. If you fight with that problem one day or at some point of the time or the other, you go on to win that, and then it does not remain a problem. Right? So that is the idea. So let us see a problematic question and then see that what will be the solution for it, right? Let us take a syllogism like I, A, or I. Let me take it I. 2. Fine. Let us see what will be the thing. So we know 2 will be like here, and this is like this. It will be like this. This is sum P is M. This is sum S is M, and this is sum S is P. If we go for the Boolean representation, this will be Pm is not equal to 0. This is Sm not equal to 0, and this is Sp not equal to 0. So we need to draw these two, and from there we need to get this one, right? So this is the idea. So let us try to draw it. Okay. So what we will do? We will draw again 3 intersecting circles and label them as S, P and M. Okay. Fine. Now Pm is not equal to 0. Now if you see P and M is not equal to 0. Now you need to put a cross mark here in this part, right? But you do not know whether you can put the cross mark here or you can put the cross mark here, because there is a line here as well, right? So what we do is that when we are in doubt, we put the cross mark on the edge. Fine. So that is a justified way, because we do not know whether the cross mark is on this side or whether the cross mark is on this side. So we have drawn it just on the line. Fine. Okay. Now let us go for the second question. Sm is not equal to 0. Now if you see S and M, okay. So here again, this is the common part. This part, right? So this is the common part. Again, you see there is a cross mark here. There is a cross. This is divided into 2 parts. So again, you do not know whether you will put the cross mark here or whether you will put the cross mark here. So for safer understanding, you put it over here. Fine. Very nice. Now, what is the conclusion? The conclusion says SP is not equal to 0. That means this part should have a cross. Now, initially speaking, it seems that this cross, either this cross is here or this cross is here. So this is going to be a valid argument, but actually it is not, because this cross could have been on this side. This cross can also be on this side. So given that understanding, this part is not having a cross mark or is not having an X mark. So irrespective of the fact that it looks, but since it is not clear, try to understand. What is the definition of a deductive argument or a valid deductive argument? That the premises provide absolutely conclusive grounds for the conclusion to be true. Now, this is not absolutely conclusive. This is a probable understanding, because this cross or X could have been on this side or could have been on this side. This cross could have been on this side or could have been on this side. Suppose in one case, this cross was actually here and this cross was actually here, then there is absolutely no doubt that there is an invalid syllogism. So there is one substitution instance which can make the premises true and the conclusion false, right? So irrespective of the fact that this cross could have been on this side and this cross could have been also on this side, but since we do not know, we have to put the crosses on the borderlines. And since we are putting the crosses on the borderlines, we cannot definitely say that the premises actually draws the conclusion. Therefore, this argument is basically an invalid argument, or you can call this syllogism as an invalid syllogism. You also know that if you see this, none of the terms are distributed, right? So apart from that, it is not breaking any rule. But then if you see, the middle term is undistributed. So if the middle term is undistributed, then there will be undistributed middle fallacy, right? So irrespective of the fact that it is I, whatever, whether it is an I proposition or an A or an E or an O proposition, whatever could have been the conclusion, there could have been more fallacies, but at least one fallacy will be there, and that will be that the middle term is not distributed. So these were certain examples. I took around 5 examples to try to make you understand that how these Venn diagrams are drawn, or the Venn-Peirce diagrams are drawn, and how we test the validity of syllogisms. However, there are more questions, more ways of solving these syllogisms, and there are more nitty-gritties or more complexities also which may come out because of certain questions. So we will take those things in the class, and we will take some interesting examples also. I will make a video of I will say very important questions or some questions for exercises, and we will try to see from both the examples, or say from both the ways. That means we will be using syllogistic rules and we will be also using Venn diagrams, and side by side we will check that what is the fallacy and how the diagram is drawn, and because of that how to read the diagram, right? So I hope that you have followed this lecture, and if you have any doubt or if you have any problem, so you can always comment, or you can always come out with questions in the class. And if certain things which, as I think that I may have gone wrong in this video in example 2 or something, so in that case I guess in example 3 I have done a mistake. So if I have done a mistake, so I will put it in the comment section, so you please check the video with the comment.